All right, so I think we'll go ahead and get started this morning. Good morning, everyone. Good afternoon. Thank you so much for taking the time to join us for this month's Detect to Protect webinar. My name is Kim Schofield from Stamus Networks, and I'll be moderating the webinar today and managing any questions at the conclusion of our session. So today's webinar is going to be presented by Mark Durrett. He is our Chief Marketing Officer, and also Phil Owens, who is our VP of Customer Solutions. Today's webinar is scheduled to take an hour, so we'll try to stop a little bit before the top of the hour so that we can take any questions that you might have. We would ask that you please use the Zoom Q&A function that's located at the bottom of your screen to type in your question, and then we'll take those at the conclusion of the webinar. And lastly, just want to remind everyone that the webinar is being recorded, and we'll send a link along with the slides and some additional information out to you early next week. So with that, I'm going to go ahead and turn the session over to Mark.
All right. Thank you, Kim. So we have a lot of really good stuff to cover today. We'll start with a review of Suricata and some of the challenges associated with building and scaling your own deployment. We call that do-it-yourself or DIY Suricata. And then we'll introduce a couple of solutions that can help address those challenges and limitations. Now, note, we will be introducing our commercial solution, the Stamus Security Platform, as part of those solutions. And Phil and I will be tag teaming throughout this webinar. And at this point, I'd like to just hand it over to Phil and let him get us started.
Excellent. Phil? Thanks, Mark. Just going to jump into a quick "What's the Power of Suricata" section, where, you know, if you're on this call, you probably already know a little bit about Suricata, but the evolution from its humble beginnings was to be a higher performance replacement for the Snort IDS, and it was the first multi-threaded IDS to help answer the question of, you know, what signatures should I be using in my IDS, because it can only process so much. And here, with the multi-threaded capability, you can actually use tens of thousands of signatures at high throughput with the solution. It's governed by the Open Information Security Foundation, so it's got its own governing body. And the very first public beta release was in December 2009, with the first full release of the product in July 2010. Now, what a lot of people don't know, you know, while it all started with IDS alerts, people aren't realizing the fact that over time it has actually evolved into adding all kinds of type of data. So you'll see here the IDS alerts, which is what made it famous and what made a lot of people use it, are great, but it's also got about 20 or so, actually a little more than 20 protocol transactions that it can parse out, recognize and parse out. HTTP, I believe, was the first one. And then from there, the SSH, TLS, and while that's encrypted data, it has the ability to grab information from the headers of the of those protocols. Also SMB, there's again over 20 different protocols that it can actually parse and give you data around. The other thing that it does is it generates network flows or logs around connections, right? So this includes your typical 5-tuple for flows, as well as a lot of other pertinent metadata around connections and size of connections and source and destination ports and IP addresses. As time has been progressing, right? They've also added the ability to do PCAP capturing, because it is sitting there and seeing all the data. So it does have the ability to record PCAPs and save those for evidentiary purposes, and also extract files from the network traffic that it's seeing happen. Suricata can be deployed both as an IDS and an IPS, so it could be inline and actually block actions as data is flowing. We have seen here at Stamus current deployments that are running at 100 gigabits per second with off-the-shelf servers with tens of thousands of IDS rules all running in conjunction with one another. So with that, I'm going to jump into the challenges and limitations of a DIY or do-it-yourself deployment of Suricata. So some of the challenges that you might run up against. Suricata is just an image, or excuse me, just an engine, and it needs to have supporting applications. It will generate a ton of logs for you, but what do you do with those logs? So you need to build a supported infrastructure around it in order to be able to utilize the logs that it's producing, as well as pull data from it. It also just needs a lot of care and feeding, if you will, to keep it going. We have seen system obsolescence due to SME churn or subject matter experts. So while you're building it, somebody may have come up and said, hey, I got a great idea. We can do our IDS with Suricata. It's open source. It's free. We'll set it up and we'll do that. That person may leave the organization. And all of that supporting stack that they have built in order to be able to do your deployment, that knowledge kind of leaves with them. So when that subject matter expert leaves, you now have to go back and say, okay, well, what was done? What did this team do, or what did this person do in order to make it all happen? And we see a lot of issues with just trying to handle that type of scenario. One of the big things that is a problem, and probably one of the things that actually helped start Stamus in the beginning, was again, Suricata is just an engine and needs a stack. Somehow you need to get rule sets and signatures and threat intelligence into the solution so that it gives you pertinent information when it's triggering on those. So you'll have to build an entire system. If you have, 10, 50, 200 Suricata sensors, something has to be done in order to be able to manage the rule sets and the threat intelligence that are actually going into the Suricata engine. Some of the hidden costs that might be seen are that stack maintenance. So while you get everything up and running, now everything is going well, you're going to have to support it, but you're also going to have to maintain it. Any patches that are going to be required for any piece of the stack, the operating system that the engine is running on, all of those things have to be handled from within, handled by you, right? With no help from outside sources, if you will. So again, that stack is built by your team and is all supported by your team. And then finally, a lack of expert technical support. Who you're going to call? So from a Suricata perspective, all of the support is pretty much handled via forums and maybe Discord channels and things like that. Even here at Stamus, we have some Discord channels specifically for Suricata type support. So that's how it's handled. But as an enterprise, a lot of times the management team wants a throat to choke when something goes wrong, and in this case, who you're going to call, right? So that's really what's happening from that perspective. So we have all these challenges, and then the next piece that I want to talk about is a little bit around limitations of a do-it-yourself Suricata deployment. First of all, it's a high volume of alerts, right? So when you plug in all of the signatures, they're going to start alerting on things. And there's no real built-in mechanism for prioritization of those alerts. If you're building your own alerts, great. Your own signatures, great. But if you're using third-party signatures, you're relying on those third-party signatures, the writers of those third-party signatures, to be able to determine severities as well as prioritize the rules for you. And in that case, there's really no mechanism to handle that prioritization based on your environment. There is a lack of advanced detection algorithms. So while you do have all the signatures and the capabilities to from Suricata, it doesn't really do anomaly detection or machine learning, or the new words, right? Artificial intelligence, those types of things aren't really handled directly within Suricata itself, right? So your based on the data just provided by the Suricata engine, right? So any of that, those algorithms can be based on that data. Again, remember that Suricata isn't just firing these alerts, but can also fire all of this telemetry data around any alerts, as well as the actual network traffic that it's seeing. So the idea of having advanced detection algorithms around that other data becomes handy. There's a lack of contextual information, so no way to add business context easily to the data that you're receiving. That business context could include things like IPs or IP ranges to be able to see the assets. So when you're actually doing an investigation, while the data is going into most likely some type of SIM or data lake that might be used, and that's where contextual data can be added after the fact. The idea of just with the Suricata engine alone, that data is not there. There's a limited asset activity tracking. And what we mean by this is, while the alerts and the network security monitoring data that is taking place, while that is happening, it's really just a stream of data coming in. And you need other tools in order to be able to put that data together to figure out what's happening on a single asset or multiple assets within the environment, or asset types for that matter. So as far as asset activity tracking, the Suricata engine alone will give you a stream of great data, but not necessarily put that into a format that's conducive to being able to look at what assets are actually involved in some type of scenario that you might face. And finally here, there is really no purpose-built user interface with the product. Now, while Stamus has created the what has been known as the serious user interface, or the Stamus interface that you can find in the SELS open source product, other than that, there's really no purpose-built user interface. You can use EVEBox to be able to stream through some of the data, but the idea of having an interface to be able to manage rules, create your signatures, as well as the ability to do hunting within the environment from a Suricata engine perspective, that's not really available right out of the box. You have to build that yourself. So with that, I'm going to turn this over to Mark so that he can talk a little bit about Stamus networks before we dive into some of the solutions that we have.
Okay, great. Thank you, Phil. Next slide, please. So some of you may not know much about Stamus networks, so please allow me a couple of minutes to introduce the company to you. So we're a 9-year-old company with headquarters in Indianapolis in the United States and Paris in France. We've got offices in 8 countries, and we got our start developing open source tools for Suricata, and perhaps best known for our turnkey open source implementation of Suricata, which Phil just mentioned. It's called SELX. Now, our commercial platform, Stamus Security Platform, is trusted by some of the world's largest organizations, including government, certs, central banks, insurance providers, managed security service providers, financial service providers, government institutions, broadcasters, travel, hospitality, K through 12, all kinds of different types of organizations, and even a market-leading cybersecurity SaaS vendor. Next slide, please, Phil. Thank you. So I mentioned earlier that we got our start in open source solutions. In fact, our company is considered the world's leader in Suricata-based network security. Our team has been working with Suricata since 2009, contributed a ton of content, really 10 times more to the Suricata code base than any other organization outside the OISF. And our commercial solution, which I've mentioned earlier, SSP or Stamus Security Platform, it's an advanced network detection and response system. It's deployed around the world, and it is based upon Suricata. And finally, we've made substantial contributions to the Suricata community over the years, both in terms of educational material and the numerous open source tools that we've developed and made freely available to anyone who's interested. And we're going to spend a few minutes talking about those at the end. But all right, thank you, Phil. Okay, so today Phil's going to walk us through two different approaches for solving the challenges and limitations that he just mentioned that are all associated with the do-it-yourself implementation of Suricata. First, he'll introduce the Stamus Security Platform, which is a turnkey Suricata implementation, and it really advances the state of the art for network security and completely eliminates all the challenges and limitations that Phil spoke about earlier, while still, and this is really important, while still bringing all the benefits of Suricata that you know and love. So if you like Suricata and you transition to the Stamus Security Platform, you won't lose, excuse me, you won't lose any of the benefits that you associate with Suricata, and you'll gain a ton. Excuse me. Next, because many organizations have made substantial investments already in homegrown Suricata sensors and would like to keep them in place, at least initially, Phil's going to describe a hybrid approach that integrates your existing native Suricata sensors with the Stamus Security Platform, and that'll allow you to gain some of the most important benefits of the full Stamus Security Platform implementation that we talk about in option 1. So, Phil, do you want to take it from here?
Yeah, I can take it. I wonder why it goes past the opening slide. These little title slides for me. I don't get it at all. But yes, thank you, Mark. I appreciate that. And so we'll start off with solution 1. Again, this will be talking about the Stamus Security Platform and a fully commercial turnkey type of solution for working with a Suricata deployment. So just combining the best of security point solutions. So I mentioned to you that Suricata has evolved to be much more than just an alert cannon, if you will, or an alert creator for you to have to deal with. And what we here at Stamus are trying to do is take the goods of some of the best network security point solutions, like the IDS. Obviously, Suricata is great at that. It's highly effective with signature-based intelligence and some and it's very extensible, right? But to the bad part of this is it's really got a lot of false positives. So I don't like to call them false positives, so I'll tell you that in just a second, and I'll go over some of these goods and bads. But really, the bottom line is taking IDS, network security monitoring. So remember, through that evolution, we've gotten lots of protocol transactions that we're actually able to parse and see and utilize for doing investigations if that is needed, right? As well as network detection and response. Now, this is something that a lot of people are, the new term in the network perspective is about network detection and response, and the idea of having anomaly detection and advanced threat protection and things like that from the network information. And what we've done here at Stamus is we've tried to take all of these good pieces and put them together into the Stamus Security Platform, right? To give you a high confidence notifications of real threats that are actually taking place. I mentioned the guided threat hunting or some type of threat hunting in a previous slide, and we give you the ability within the product to be able to do that and hunt with that added data from the NSM portions within the user interface itself, and open integrations to other parts of your security stack, whether that be a SOAR, a SIEM, those types of things can all be integrated with the Stamus Security Platform. We're trying to do this by eliminating most of these bads, right? And in order to do that, we're talking about too many false positives from an IDS perspective. And again, I don't like the term false positive, and here's the reason why. Odds are that IDS actually saw something and it populated. The question is, was it useful for you, right? And then from a network security monitoring perspective, what it lacks is the an external analytics engine, or it's very resource intensive as far as being able to do that. So we're trying to make sure we have a single engine to do everything that you see here. And then from a NDR perspective, some of those bad items that we're trying to handle, really the biggest one is the lack of visibility or evidence that that you see. And we try to give you all of that within the user interface. So the Stamus Security Platform can be deployed in a lot of different ways, right? So you might deploy it in your corporate headquarters. You might put it in a private cloud or your own data center, a public cloud, or branch offices. And what you see there along the bottom is all of the different deployment options for the Stamus Networks probe. And this is the probe that's actually built on Suricata, right? So the Suricata Foundation is being used here. Now, in order to solve some of the challenges that we talked about with regards to managing all of these probes, managing the operating system updates, the Suricata updates, all of the pieces of the stack around it, we have what's called the Stamus Central Server. And what this does is it actually allows you to manage your threat intelligence and push those to the probes as needed. It allows you to manage all of your all of the data that is coming in. We actually have a data lake built into the Stamus Central Server, and then it can also deliver data to a SIEM, an IR ticketing tool. So it's a single place where you can go and manage your entire deployment of all the Stamus network probes that you see. And those network probes are doing a lot of capturing of the data, as well as storing any PCAPs or files that you may have set up to store, and producing all of the metadata and processing all of that data so that it can be delivered to that Stamus Central Server. Something I hid there is the little cloud. I think if I go back, you can, if I go back, you can see that we can be deployed inside of a public cloud, including AWS, Azure, and Google Cloud. So to give you a little bit more understanding, what we've done is taken the Suricata engine, which you can see here, and all the network traffic that is coming in, and then we process that and enrich it. And all of this is happening on the Stamus network probe. So this big rectangle that you see here in the dotted line, that is all considered part of the Stamus network probe. So all of the enrichment and everything is happening right there. We can send data from the Stamus Networks probe to an external ELK data lake, so Elastic data lake, or to even a Splunk instance if you're utilizing Splunk as a SIEM. But we also have some automated triage, which I'll talk a little bit more about in the coming slides, and some stateful logic that's utilized for detecting things like possible homoglyphs that might be seen, where you're using a Latin A versus a Bulgarian A inside the URL to try to get to a phishing site or something, and being able to detect that. Then when all of that data goes into the Stamus Central Server, we have things like anomaly detection, which is our sightings, the enriched alerts with all of that added context, declarations of compromise, which is actually where we're whittling down a lot of data, and I'll show that in just a second as well. We do have some machine learning for beacons. We can display an attack timeline. All of that is done right within the Stamus Central Server. We also have a way to monitor assets called our host insights. So you see cards all around the host insights pieces. And those cards include asset types and roles and services and ports that have all been opened by those assets. Things like user agents and TLS agents that might be of interest from a analyst perspective. Right. So we talked a little bit about the declarations of compromise and how do we go from 2 million IDS alerts, right? 7.2 billion protocol transactions. So this would be what Suricata would give you all by itself, right? 2 million IDS alerts, and this is, over, I believe, in this case, it was over a 24-hour time period that we were looking at the data. And then from there, we've correlated and done some automated triage, which is that next piece. And that reduced the actual events that were seen from an IDS perspective down to about 5,000. So instead of 2 million IDS alerts, we're down to 5,000, but still too many for an analyst. And then with advanced algorithms and some high fidelity detection that we've created, we're actually able to show serious and imminent threats of assets that are under attack. And in this case, we had 2 serious threats on 5 impacted assets. And those are what we call our declarations of compromise. These are things that I like to call, and I'll watch Mark's screen, I like to call pants on fire events, right? So he hates it when I say that, so I want to do that just for him. Just to give you a quick view and talk a little bit about like the correlation and automated triage that we were talking about, or specifically the automated triage, the alert triage. In this screen, what you're looking at is a dashboard of our hunting interface. Now, what's really nice about this is from a Stamus Security Platform perspective, in a typical IDS, you're able to create suppressions and create thresholds, and you usually do that within Suricata based off an IP address, maybe IP port, source destination, and a signature ID in order to be able to suppress some of the data that you see here, or triage some of the data that you see here. What's really nice is that with this interface, you can actually use all of the metadata that is produced around any of the signatures that are firing. And that includes, in a lot of cases, the protocol information as well. So you can use things like HTTP user agent and maybe categories or severities in order to create what are known as filters. And then those filters can in turn be suppressed, threshold, or tagged, and not utilizing your typical Suricata suppression mechanisms that are there, but utilizing a lot of different data that you wouldn't normally think of for doing a suppression with an IDS. So in this case, some of those automated triages is the ability to tag. So I talked suppression. I also mentioned tagging. We have a couple of tags here called informational and relevant. So basically when data comes in, it's untagged, and then you can actually determine if you want to tag a certain filter as informational or relevant. Now you'll notice that we have 2,800 alerts in this demo environment. So it's not a lot, but it's still a bunch for an analyst to have to go through and figure out, okay, what is it that I'm looking at from these 2,800? But if I've gone ahead and done some of those taggings that we just talked about based off of the filters, I can actually reduce this down. Now that I've turned off informational and untagged, I can reduce this down to only 476. So just some of the automated alert triage that's built into the system that you can utilize for making it easier for an analyst to be able to do things. Now, one of the things that can also be done, not only can you tag and suppress items from this interface, you can also escalate an item to what we call our declarations of compromise. And what you see here is the operations center dashboard. Now you'll notice along the top of this dashboard, we have some key indicators there. So the analyzed traffic, what this is all the aggregated traffic from all of the probes and how many have actually been how much has actually been aggregated. So all of the traffic that has been seen, and then dwindling that down to the number of events, in this case, 5.1 million events. That includes those flow records and protocol transactions we've been talking about. Now you'll also see here the number of alerts, those 2,800 we talked about, and then declarations of compromise. So we can take threats on an asset. So these are real threats on an asset. One of these threats could be a aggregation of multiple alerts to determine that these things are actual threats on an asset that you really need to look at. And we'll take the asset and we can plot that within the cybersecurity kill chain. So again, this is our demo environment, and because of that, we wanted to let things play out. So you'll see both of our assets here are actually in actions on objectives. But they could fall if we caught this at Maldoc on this screen. If you can read that, we could have caught this at delivery for that asset to keep some of these other things from happening. So that's what the Operations Center dashboard looks like, and where a junior analyst might actually just come in and take a look. Is there anything that I really need to act upon now, and then start doing their investigation from there. The other real key piece of information that we have is what we call our timeline for our serious and imminent threats, or the declarations of compromise. So in this case, I'm looking at a particular asset, and I'm able to see the timeline and step-by-step any anomalies that may have taken place. So you can see there was a new TLS fingerprint detected, and then all of a sudden Purple Fox switched the asset into exploitation. So we can see how it moved from exploitation to command and control, and what caused that to take place. We can even see when new malware might be first detected on the system, and different anomalies that may have taken place, things that have never been seen before within the organization, right? So that's about the Stamus Security Platform, the full commercial version, and how that works. And just real quickly, some key differentiators of why the Stamus Security Platform. We give really greater visibility into threats by using multiple detection technologies and a guided threat hunting interface. So purpose-built for the data that you're receiving from the Suricata platform. That is the basis of what we've built upon. We actually have some privacy protection. Right, it's not a SaaS application. So if your organization requires that you can't send any data to a cloud environment, you can actually keep all of that data. All of our analytics are built on the system itself. While the system can be deployed in the cloud, it doesn't have to be. And that means you can keep everything within your organization. There are transparent detections with detailed evidence. So we saw some of the timelines and stuff, but we can also break that all the way down into what signatures were actually firing, if there were signatures that caused those declarations of compromise. And it's built specifically for enterprise scaling. The interesting thing, and I'm going to talk a little bit more about this in the solution 2, is that you can use our probes, the Stamus Network probes, or you can use your own Suricata sensors. So if you've made an investment to go in and build out your own Suricata sensors, we've actually got a route for you there as well. The other last thing I want to mention on this page is it's open and extensible. So we do those declarations of compromise can kick off webhooks, which can do things like create block lists within a firewall, or it could quarantine a asset in the environment utilizing an EDR. It can send a message to the SOC team in a Slack channel, all kinds of things that it can do, as well as the entire platform is all based off of a REST API. All right, so that was solution 1, and a fully commercial solution. So as Mark mentioned before, that was something that we were definitely going to talk about today. This is solution 2, and more of a hybrid SSP open source approach. So very similar to solution 1. Like I had mentioned, you have the ability here to utilize all of your own Suricata, native Suricata sensors. So if you've deployed Suricata, you can keep those deployed, you can keep using them, and you can then add the central server to the mix to help actually manage those, right? And then it also gives you some of those added capabilities about being able to get the data into a SIM, and being able to, with webhooks, maybe create tickets within a ticketing system, or going into a data lake, or triggering a response from a SOAR. Very similar to the commercial version of the full commercial version of the Stamus Security Platform, but utilizing your your actual Suricata sensors that you've deployed. Now, one of the differentiators, or one of the things in how this kind of works is, as I mentioned earlier in the commercial solution, most of the processing is taking place on the probes themselves with the Stamus network probes. And what that does is it helps with scalability and a bunch of other things. But from a Suricata perspective, we can't do a lot of that processing right on your sensors because it's the code that's part of our appliance, if you will. So we've added that a lot of the capabilities for enrichment of data and things into the Stamus central server for a Suricata sensor, a native Suricata sensor. This will give you the purpose-built user interface that we talked about and I showed you in the previous solution. It will actually allow you to manage all of the rule sets and threat intelligence for the Suricata deployment that you currently have. The protocol and flow data logging and analysis all coming into the system here. The reason I want to mention that is the only real change is that the logs will get pushed to the central server so that you can actually have all of that data for the analyst within the purpose-built user interface. So I will also mention that the guided threat hunting is available that I showed in the previous solution. And then it's really doing these things. It's alert data enrichment at the Stamus central server, automated event triage that we talked about, as well as context via network definitions are all available. So business context gets added to each of the alerts. And we really didn't talk about that in the commercial solution either, but that I will say is one of the things that can be added as part of the enrichment process within the solution. Then finally, you do get those high fidelity declarations of compromise, even from the hybrid solution. So what I'd also like to point out is it's easy to transition from native Suricata to the Stamus Security Platform full commercial version. So basically, you get all of those things that I just talked about. They're purpose-built. You can see all the Suricata sensors going into the Stamus central server for doing all of your management from there. And then you can start adding any way that you would like, sorry about that, any way that you would like, Stamus network probes. And in certain instances, because this is, it is an appliance, right? So depending on how you're deployed your sensors, if you've deployed them on hardware, it is conceivable that same hardware could be utilized to install the ISO for a Stamus Networks probe to create an actual Stamus Networks probe from a Suricata sensor. Virtual machines also very similar. You can stand those up, and the Stamus Central Server can actually handle data being input from both legacy Suricata sensors, or native Suricata sensors, I guess I should say, as well as Stamus Networks probes all at the same time, until you get to a point where maybe you want to make the full move all the way over to the turnkey system with Stamus Networks probes, the Stamus Central Server, and all of the features and benefits that are actually available to that solution. So there is an easy transition from native Suricata directly to the Stamus Central Server and Stamus Security Platform. So with that, I'm going to jump into real quickly comparing these three approaches. So I know this is a lot of data right here. I'm not going to go through each and every one of them. We will be, I believe, sending out this entire slide deck. But basically, with the do-it-yourself Suricata, it's an engine. It's going to give you the NSM data, all the network protocol data that we've been talking about, as well as IDS alerts. And that's pretty much it. Everything else you have to build all by yourself, or all with your team. Everything has to be built around that. With the hybrid and open source solution, you can see we go everywhere from the high fidelity declarations of compromise all the way up to the purpose-built user interface for investigations and hunting. Then the Stamus the Stamus Security Platform with the Stamus Networks probes, the full commercial solution is fully supported, right? It's a complete turnkey system with probe management. It also includes some of the host insights that I was talking about, the asset-based approach, as well as dynamic data sets for IOC matching. Those types of things are all kind of added in, things that have to be done at the probe level in order for it to work. So the benefits to the business are really gain control over the IDS. Some people call it alert cannon. Every now and then I'll call it a machine gun because cannons can only fire one at a time. And yes, they're really big, but there's not a lot of them. So it helps gain control over that with the declarations of compromise and the automated triage that can be utilized. It will improve visibility. It gives you, we try not to hide any details, right? So bottom line is if a declaration of compromise happens, it's not a black box. Here, we think you have TrickBot. No, here we think you have TrickBot, and here's the reason why, and here's the signatures that caused that. Here's the samples of what we saw. So all of that data is available. You can reduce your reliance on in-house developers to build all the stacks and pieces around, because this is a turnkey solution, as well as reduce the time to respond to incidents. Because if we're bubbling that up automatically, we can deliver that in a Slack channel, and all of a sudden you're responding in minutes instead of hours that it might take a back-end system to process all of that data. So with that, I'm going to turn this over to Mark, and he's going to talk a little bit about open source resources.
All right. Thank you, Phil. Next slide. Thank you. So I want to take a moment to introduce just a few of the many open source tools that our teams contributed to the Suricata community. Hopefully one or more of these can help you as you work to leverage the power of Suricata within your own organizations. So starting with the left and moving to the right, we already mentioned Selks. And if you're new to Suricata, this is one of the best places to get started. It's a complete turnkey implementation of Suricata with a built-in user interface that includes a hunting and incident investigation interface and a rule manager. It's available as a standalone ISO image or as a Docker package. So there are a lot of interesting deployment options there. For our Splunk enterprise security users, well, we've created a Splunk app that provides a number of dashboards and query tools for using with your native Suricata sensors. And just this year, we introduced what we call Jupyter Playbooks, which are a set of Jupyter notebooks dedicated or created for analyzing Suricata logs. And then last year, we introduced the free Suricata rule set specifically focused on detecting lateral movement in Microsoft Windows environments. And so this is a set of Suricata rules specifically focused for that purpose. One of our most popular tools since we introduced it last year is the Suricata language server. So this is a plugin that adds syntax checking, performance guidance, and auto completion to your favorite text editor. And that's designed for Suricata signature developers. So when you're writing rules, it helps accelerate that process. And finally, we have GopherCap, which is a really innovative PCAP manipulation application that gives you accurate playback for extra large PCAP files directly from their tar archives. So pretty cool package there. Now, information about all these tools can be found on the Stamus Labs section of our website at stamusnetworks.com. Next slide, please. And in November of last year, 2022, we published the Suricata Analyst Guide to Suricata, the Security Analyst Guide to Suricata, excuse me. So this is the first practical guide for unlocking the full potential of Suricata. This is available in electronic form. We have hard copies that we bring to most conferences and trade shows. If you happen to stop by our booth, we can get you a hard copy, but it's available digitally as a PDF or in e-reader format. So this is written really for SOC analysts and threat hunters who use Suricata to gain insights into what's taking place on their networks. And the book really provides a ton of information and in-depth overview and analysis on some of the most important Suricata features. Next slide, please.
There you go, sir.
All right, thank you. I just mentioned Stamus Labs. That's got access to all of the open source tools that we've talked about. Some, in addition to the ones I just mentioned, are listed there. We have a resource library with lots of materials, case studies, videos, white papers, etc. And then a blog that we publish articles on once or twice a week. And I checked this week, there are over 60 articles on Suricata related topics alone. And so a lot of valuable resources. And with that, I think we'll wrap up and transition over to Q&A. Kim, I don't know if you've got any questions that have come in since we've been talking, but I'll hand it back over to you.
Yeah, I do.
Okay.
Thank you. So just a reminder, if anyone has any questions, just type those into the Q&A. And we'll take those as they come up. All right. So Phil, when you were talking through the first solution, a question came in about PCAP files. So can they take a PCAP based on timeline, so plus or minus 10 minutes, for the host that's involved once an alert has been triggered, and then is that PCAP exported?
So currently, I don't have the ability within the UI to do it based off of timeline. So what we're doing with the Stamus Security Platform is when an alert fires, we are capturing that entire session as a PCAP so that it can be saved for evidentiary purposes and exported at a later date, or whenever it's needed. So in that aspect, yes, it can definitely be exported. I mentioned that all of our stuff is based around a REST API, so it could be exported at the time that it actually takes place. There could be an automation put in place. Now, as far as the time frame on a particular host over a period of time, that is definitely a feature request. You're not the first one to ask the question, and we are looking at building that for a future release of the product. The ability to actually, because we're going to have buffer space, do we grab that buffer for that particular host, that asset for the period of time? And it might be plus or minus 10 minutes, it might be plus or minus 5 minutes, or even configurable. But the answer is that is something that we're looking to add to the product.
Excellent. All right, and hopefully that answers your question. If you had anything additional you wanted to ask, feel free to add that. All right. Bill, thank you there. All right, so I have a few others. So I have someone that says they're a Selks user. So it's kind of a two-part question. So one, can our commercial solution manage Selks sensors? So that's the first part. And then second, how would they transition from Selks to a paid solution?
So the first solution is yes, it can be done. It is Suricata, therefore you can use them as Suricata sensors within the Stamus Security Platform and see the data rolling into the central server versus everything happening in Selks and the turnkey. And at that point, once you've gotten there, you can actually start removing some of the Docker containers on the appliance that you actually have Selks deployed on, so that most everything will actually roll into the central server, and therefore would be redundant to the things that are actually on the Selks platform. So yes to number one. Number two, how does someone transition? Right, I think is what you mentioned. And currently the transition is very similar to what we talked about in solution 2. So once you have Selks deployed, you can start making those your Suricata sensors with the Stamus central server, and then start adding Stamus Networks probes to the solution. So that's how you would do that. to make that transition. So.
Excellent. And that was a good slide. I think that was a good step-by-step there to show how that works. All right, so the next question I have, so you did talk about us working in the cloud, but I had a specific question about how do we work with Suricata deployments in the cloud?
So the central server can be deployed in the cloud, as I'd mentioned before. So you could actually keep everything in a single cloud instance, if you will. We also have the ability to, for Suricata instances, you're gonna want to deploy wherever that's closest. I will tell you that we do transfer data TLS. So if you want to go outside the cloud in order to see your data. Now, if you do decide to make the transition to the Stamus Networks probes, we also offer the ability on the probes to do open VPN connections between the Stamus central server and the actual probes for doing all the management and collecting all the data. So from a Suricata perspective, we're going to transmit the data to the Stamus central server over a TLS connection, and then for the commercial version of the Stamus Networks probe, we can take that one more step and have a VPN between the probes and the central server.
Excellent. All right, that was all the questions that I have, but I'll give everyone a few more seconds here if anybody has anything else they'd like to ask. Again, just a reminder, everything has been recorded today, and we'll send out the slides and the recording, a link to a video, and also some additional materials. Some links that Mark mentioned as well. We'll include those in an email that will go out early next week. So keep an eye out in your inbox for that email. All right. Well, I don't see any other questions coming in, so I just want to thank everyone for taking the time to join us today. And Phil or Mark, you guys have anything else you want to add?
Thank you.
Nope, thank you very much. I know that
All
time
right.
is precious, so thank you for spending that time.
Oh, no, someone did pop in. They just said thank you.
Nice.
Thanks for that.
Thank you.
All right. Have a great rest of your day. Take care.
Bye-bye.
Bye-bye.